So we're going to use the Pythagorean theorem to solve some cool problems. In particular, this one right here, this one is one of my faves because it combines my love of algebra with my love of geometry. Oh yeah. So here we go. We're trying to find the value of x, and we want it in simplest radical form. I have a right triangle, so what am I going to use? The Pythagorean theorem. A squared plus b squared is equal to c squared. I don't really like pink. Apparently, I'm not man enough to like pink. All right, so, well, my a value is 2. So we have 2 squared plus 6 squared is equal to x squared. 2 squared is 4. 6 squared is 36. It's equal to x squared. 4 plus 36 is 40. Is equal to x squared, square root, square root. So I get x is equal to 40. But simplest radical form tells me I need to convert the square root of 40 into its simplest radical form. So what goes into 40 that is a perfect square? Oh, that's not too bad. It's 4. So the square root of 4 times the square root of 10. The square root of 4 is 2 root 10. All right, are you as pumped for this next problem as I am? I'm pretty pumped for it. All right, so we have another right triangle, but this time we have variables in both a leg and the hypotenuse. All right, so here we go. So we have our x squared, our a value, plus our b value squared, so that's 4 squared, and that's equal, oh shoot. I've already made a mistake. My leg value is x minus 2 squared plus 4 squared, and that's equal to my hypotenuse, which is x squared. So x minus 2 squared is x minus 2 times x minus 2. Don't fall into the trap of saying it's x squared minus 4. It's not. Or plus 4. So we have x squared minus 2 times x squared minus 2, which gives me x squared minus 4x plus 4, because we're going to get a linear term when we multiply a square binomial together, right? And we have this other plus 16, because 4 squared is 16, and that's equal to simply x squared. Oh, no way, check this out. We have an x squared on both sides of the equal sign. So this x squared will cancel out with this x squared, leaving me with a 0. So I have negative 4x plus 20 is equal to 0. Well, okay, now it's just a linear problem, right? So subtract 20 from both sides. We get negative 4x is equal to negative 20. Divide by negative 4. Divide by negative 4. And I get x is equal to 5. Oh, that makes this 3. And I really didn't need to do this, did I? Because it's a right triangle 4, right? 4. This is a 3, 4, 5 Pythagorean triple. Speaking of Pythagorean triples, we have one of those coming up. For question 2, Randy's building a rectangular picture frame. Why he didn't go to the store, I don't know. It's an art class where you make things that you give to your parents that they don't really want, right? Oh, I didn't say that. Okay, so we know that it's at a ratio of 1 to 3. And I know that it's going to be 1 times some scale factor and 3 times some scale factor to keep that ratio of 1 to 3. And we know the diagonal has to be 12 centimeters. So how wide should the frame be? Round to the nearest centimeter. All right, so I know that x squared plus 3x whole thing squared has to equal 12 squared. So I have x squared plus 9x squared is equal to 144. Almost see that, right? So, well, x squared plus 9x squared, that's 10 total x squareds. So I have 10x squared is equal to 144 divided by 10 divided by 10. And I get x squared is equal to 14.4. All right, square root, square root. So I get x is equal to, now I don't know the answer to that off the top of my head. So I'm going to pull up my calculator, and I'm going to go 14.4 square root. And so x is equal to 3.8. Well, it says rounded to the nearest centimeter. So I can safely say that this side is going to be 4. Well, just because it's the right thing, let's figure out how long this should be. All right, so then I'll multiply this by a scale factor of 3, and this is going to be 11. So a 4 by 11 should have roughly a diagonal of 12. The Pythagorean triples. It's like a good friend coming back after a long vacation. So a Pythagorean triple, you'll remember, is a right triangle that has integer side lengths. So each side length is a whole number, an integer. So, all right, let's see what we get. So we got 14 squared plus 48 squared is going to be equal to my hypotenuse squared. 14 squared is 289 plus, okay, I'm not gonna pretend I don't know that off the top of my head, but luckily the calculator does. So it's 2,340 is equal to c squared. Well, let's add the two numbers together, the two squares of the side lengths, and so I'm gonna add that with 289. Oh, yeah. Hold on a second. 48 squared plus 289. But wait a second. 14 squared? Oh, geez. 14 squared? You should have caught me on that one. Is 196. 196. All right, so now let's add that to our, I guess I should have just used the calculator the first time, right? So we get 2,500 is equal to c squared. Now this is a perfect square, because when I square root it, I get 50. That's what I get. So is this a Pythagorean triple? Yes, it is. But wait. I can't help but notice that 14, 48, and 50, they're all even numbers, which means I can divide them all by 2. So a Pythagorean triple, you're not going to hear about 14, 48, 50 triangles, because the parent, the foundation of all these triangles, we can go back. We can factor out at 2. And so we get 7, because 14 divided by 2 is 7, 24, 25. So that is the Pythagorean triple that we're working with, just with a scale factor of 2. All right, so let's take a look at the next problem. So we have 4 squared, because that's definitely a leg. Oh, shoot, they're trying to be tricksy. They didn't give us this leg. So we have plus x squared is equal to 12. All right. So that's 16 plus x squared is equal to 144. I don't like the way this is looking. This does not look like it's going to work out right. So 144 minus 16, that's not a square number. So when I take the square root of it, I'm not going to get a whole number. I'm going to get an irrational number. So is this a Pythagorean triple? No, it is not. I'm trying to pass it off as a Pythagorean triple. Okay, finally, we're going to tell whether or not these side lengths will give us a triangle. Not only that, we're going to figure out if the triangle is obtuse, right, or just a cute triangle. All right, so we have, 5 plus 7 is 12. 12 is bigger than 10, so this could work out. And so we're going to have 5 squared plus 7 squared, and we don't know what that is. We don't know if it's equal. We don't know if it's bigger, less than, or greater than. So we have 10 squared. I'm going to leave that blank. So we get 25 plus 49, and we have 1. Oh, yeah, this is not equal. No, this is going to be smaller. So it's going to be less than, which means we have an obtuse triangle. Well, let's try B. 5 plus 8, 5 plus 8. 5 plus 8 is only 13. 13, Mia?
What?
Is 13 bigger than 17?
No.
It is not bigger than 17. This does not make a triangle.
No.
No. The nerve of them trying to give us a triangle, saying this is going to be, it's not going to be a triangle. It's just going to work. So can it be acute, right, or obtuse? No, it's not even a triangle.